So one big tech company that's been sort of lagging on the AI front was Apple. Early this year, it scrapped its autonomous electric car project and said that it's pivoting to AI. And there's been a lot of talk about what it could do, improving Siri, the M3 chips, on-device large language models, etc., but nothing too concrete, nothing that we could quite sink our teeth into quite yet until today. Apple researchers develop AI that can see and understand screen context. Another headline was Apple researchers achieve breakthroughs in multimodal AI as company ramps up investments. Some people have even mentioned that this new model can beat GPT-4. And here's a paper that Apple published just a few days ago, RULM, Reference Resolution as Language Modeling. And this paper that they published, along with some of the other rumors that are floating in the AI rumor space, got me from almost kind of dismissing Apple as a potential giant competitor in the AI space to all of a sudden being really interested if they are indeed building what I think they are building. Because what I think they are building is agents. They're skating to where the puck is going. But let's rewind just a little bit. Here's the thing. There are rumors that Apple is in talks about potentially purchasing Perplexity. We've covered Perplexity. It's kind of a different approach to doing online web search, right? So similar to how Google and Bing do it, but with a large language model. Here's what that kind of looks like. So let's say we ask it, we're going to say Apple buying Perplexity, and we click search. So it looks through all the various sources that are available online, whether that's YouTube videos, Reddit posts, various news sources, and then it uses a large language model to answer that question for you by summarizing what it found. So it's not sort of making stuff up. It's not taking a stab at it. It's not guessing. It sort of reads over the sources for you and summarizes them. Now, of course, the answers are as good as the sources, right? So if the sources have the wrong information, this will give you the wrong information, but it's built to be similar to how scientific papers cite their sources, right? So if you say, we're building this paper based on the assumption that X, and they link to a paper where they discuss why X is true, right? So they're sort of citing another paper to say this is why we believe it. If you notice these little things here, one, and for example, here's a good example. So about Perplexity AI, right, tells you what it is, and it gives you sources, 2, 4, 5, etc. And the model that you use to summarize it, you can change it. You can use Claude, you can use GPT-4, you can use Mixtral, you can use pretty much whatever. They're pretty good. They're really fast at getting the latest models to be available for use if you wanted to switch. Now, a lot of people are saying that this could potentially be the next iteration of how online search works. So instead of typing in something into a search bar and then getting 10 blue links, the way that we search online is this. We can do image search, video search. We can even generate images if we wanted to. If we needed our answers in a certain format, like if you're doing a report, Perplexity has that built in. You can create a custom search that organizes that information into whatever subheadings or columns or however you want it. It will organize it that way. So when they're saying that there's rumors and speculation that Apple is allegedly in talks to acquire Perplexity AI, however, there's no definite confirmation of this potential acquisition. So this, I would say, is a pretty good summary of what's happening. There are rumors. There's no confirmation of whether they're true or not, but certainly something like this would make sense. It would give Apple more power with Google because they would have basically their own search engine. They also would not need to develop their own LLM model. They wouldn't have to necessarily build one from scratch. It seems like they are working on it potentially, but the big thing that a lot of other people are struggling with is the vision aspect, the computer vision. So similar to how GPT-4 with vision works, or Gemini has their own version of vision. I mean, they're pretty good at recognizing images. They make mistakes, but when we try to use them as agents to navigate the web, they're pretty bad. Everything that I've seen so far, it's not anything that you would use to do any sort of complex tasks. If you're taking a screenshot of this page, for example, and you're saying something like, start a new search, right? Maybe it might click on home and then click on here and start a new search, or it might fail. And if you give a complex task where multiple things have to be kind of strung together to achieve a certain outcome, like go and do research on the best headphones and then check pricing of those headphones across various sites and then purchase those headphones, right? Any mistake anywhere along the line means that it's not able to complete that task. So even if it accomplishes 90% of those subtasks correctly, right? It kind of compounds to where it won't get to the finish line, so to speak. And that's one area where a lot of different people are proposing different solutions. That's one area where we need to have some progress, some improvement to have very capable autonomous agents. All right, so that's one piece of the puzzle. There are also rumors that potentially maybe Apple iOS could pull in Anthropic to help them run some of the on-device features, some of the on-device technology, meaning that you would have a large language models like a GPT or Gemini inside the Apple device that you're using instead of having it always be connected to the internet, to the cloud. That's also why kind of some people are saying that Apple could have an advantage because of the chips that they use. The on-device chips could run those on-device images. They could run those on-device large language models. Why is on-device so important? Isn't the phone or the computer, isn't it always connected to the internet? Why do they need to be on device? Well, that brings us to this paper that they just published. This is end of March 2024. It's by Apple. So Apple published this one. This is the Realm reference to resolution as language modeling. This is the thing that some people are saying outperforms GPT-4, which, while maybe not quite true, it's certainly not hyperbole. It's in the same ballpark, but here's what I would be keeping in mind. So imagine something like Siri, a voice assistant that you talk to. Imagine something like this that's able to basically read all the text online and understand what it's looking at to be able to navigate it effectively alongside with some on-device large language model. I'll come right out and say it. What if in the next few years, Apple devices, all the Apple phones, iPhones, all the laptops, all the stuff that they have, what if they do in fact develop the best performing AI agents that run completely on device? Meaning that instead of clicking on things and typing things in, instead of writing emails or adding things to your calendar or going to Amazon and doing shopping or anything that you do, like how you interact with any device, instead of that, you have your own AI agent. It sounds like Siri. You tell it what to do, and Siri then goes and does it. You tell it, hey, email my friends, see when they're available, add it to my calendar, then send me a text reminder when it's time to go to that event or whatever, or do research for the best headphones, go on Amazon and purchase them. I mean, we've seen this idea before. There's multiple startups that are kind of going after that right now, and they're all very exciting. People are throwing tons of money at it. But could Apple beat everybody to the punch and launch their own on-device, as in on-Apple device, autonomous AI agents? Certainly that would feel like it would give them a massive, massive edge in this sort of war for AI supremacy. But let's get started. They start with saying basically it's important but quite hard to get these agents to understand what's happening on the user screen as well as on the various screens that are running in the background, like if you have multiple apps open. And they're saying while LLMs have been shown to be extremely powerful for a variety of tasks, their use in reference resolution, particularly for non-conversational entities, remains underutilized. So what does this mean? Let's break it down just a little bit, because this is kind of the big point of all of this. Basically what it means is this. If, let's say I show you this screen that you're looking at right now, and I say, what does the speaker want in table 1? Right now, it might take you a second to understand what I'm talking about, but I feel like most people, will figure out, okay, I'm talking about table 1, right? So this is table 1. And so you always see, okay, speaker. So speaker is either the user or the agent. So you might translate that to mean, okay, so he's asking, what does the user want, right? But the point is you'll kind of figure out that this is what I'm talking about, right? With the vision models of GPT-4, Gemini, all the other ones, this is where it misses quite a bit. It might not be able to find this, or it might not understand the reference, the context of what I'm talking about, because while it might understand what this means when we're talking about text, right? So an LLM, large language model, if you're just asking it questions in text form and spitting out text form answers, right? It's pretty good at that, right? Not perfect, but that's kind of what they do. But then you also have like the eye, where it like looks at something, tries to understand it. It tries to translate what it's seeing, so the pixels on a screen, into words, and then answering with words, right? And translating into some action on a screen. I hope that makes sense, right? Because to us, it's almost like the same thing. If I say, click on the eye, right? So you click here, like you don't have to think about it too hard. But with language models and vision, it's kind of like this back and forth translation. It has to look at the image, translate that into text, reason about it using text, and then translate that into clicking somewhere in the image. And this is where we ran into a lot of problems with it. This is where it screws it up, like a lot of the time. So the question becomes, how do we help it translate visuals into words? And so this Apple paper continues. The paper demonstrates how LLMs can be used to create an extremely effective system to resolve references of various types. By showing how reference resolution can be converted into a language modeling problem, despite involving forms of entities like those on screen that are not traditionally conducive to being reduced to a text-only modality. So I gotta say, I feel like in a lot of these papers, like this sort of style of academic writers where they write for other sort of academics or experts in the field, I feel like that's slowly going away. A lot of the more modern papers in the AI space, at least, I'm seeing they're simplifying things where they can be simplified. If you can say something in a easier to read way, when you can say it without losing some meaning, you should do so. I feel like here they're using too many big words to try to, where maybe they're not as needed. I mean, they're basically saying like, how do we take a picture of something and turn it into words so that an LLM model can more easily interact with it? And they're saying they benchmark against GPT 3.5 and GPT-4, saying with our smallest model achieving performance comparable to that of GPT-4 and our larger models substantially outperforming it. And I think this is the big thing. Because stuff like this, if it works as advertised, could become kind of the go-to way of running these vision/language models. And this would be a pretty big breakthrough for agents, for robotics as well, perhaps, and just in general for computer vision. So they start with human speech typically contains ambiguous references such as they or that, right? And we as humans, we kind of, figure it out based on context. And this is what's needed for users to be able to naturally communicate the requirements to an agent, an AI agent. And it's crucial if we want to have a true hands-free experience in voice assistants, right? So they're kind of approaching these AI agents first and foremost as a voice assistants, right? So they can have Siri be that autonomous agent. Table 1, what does the speaker want? Here's what the speaker wants. User, the speaker is saying, show me pharmacies near me, right? The agent returns a list, let's say it's, 10 blue links or whatever. And so here the user can say a number of things. Now, if he or she says, call the one on Rainbow Road, right? That's pretty straightforward, right? The LM model can probably understand that. Call the bottom one, that's also should be fairly obvious, but I've seen certain examples where the vision models kind of manage to screw that up as well. And of course, call this number, a number that's present on screen. This could be probably the most vague one potentially. I would say, I would feel like this one might fail the most, especially if there's multiple numbers present, right? Maybe the user, if this is the screen, right, and the user scrolls down and then here's one number and here's another, right? He might be referring like the one on the center of the screen. I call this number, right? But there's like several numbers on the screen, like that could be confusing. And so they're saying here it's immediately apparent that it would not be possible for the agent to understand or complete the user's query without the ability to use and comprehend context to answer that question, to do that action. And there are multiple contexts needed, the conversation plus the on-screen context. They talk about how having a model that can do this reference resolution, right? They're saying that having it be a little bit more modular, like having it be its own standalone model, like a module that you can swap in and out with improved versions. So similar to, with an agent, right, you might have like this LLM model that's doing like the reasoning and thinking about what's supposed to be doing. And then on this side, you have your kind of the action model that like executes and clicks on things. And this reference resolution, let's say RR, somewhere in the middle, right? So the LLM and the RR, they're figuring out kind of the context and what needs to be done, right? Then the LLM says what needs to be done to the action module. This would kind of be like how that agent would work, how to perform all the tasks you need while interacting with the screen that you're using. They're not necessarily saying this, but the point is like they're saying having this thing be modular would be a good thing. It could be beneficial. And in this work, they're advocating for the use of relatively smaller language models that are fine-tuned for specifically and explicitly for the task of reference resolution, right? So this idea of reference resolution, this sort of understanding what's happening on the screen and kind of tying into the context of what's happening, they're saying this would be a small, standalone large language model doing this. And that one might be communicating with the larger, the smarter, sort of the bigger large language model that's doing the reasoning. Which this is kind of a theme that we've been seeing in a lot of different papers, the idea of stacking and combining different size language models, different AI models each fine-tuned with their own thing, like stacking them and combining them in certain ways seems to be very, very effective. Because something like this could be much faster at certain tasks, much better, but completely useless for other tasks. So having it be like almost a tool for the large language models that is doing kind of like the decision making, that could work very well. And here's where they're talking about more about vision, right? And the problems with vision. So they're saying, however, the biggest challenge with adopting this technique for the general reference resolution task in the context of a voice assistant. So again, this thing that figures out what does the user mean when they say, call this number, right? Given a list of numbers on the screen, like what does that mean? That's context resolution or reference resolution. So the challenge there is just resolving the references to entities on the screen and using their properties. In other words, getting the LM to informally speaking see. Wow. Okay. They could have said that a lot easier, I feel like. But the point is just like how we see things on screen and we tap it, right? When can a child start doing that at 2, 3? What kind of interacting intentionally with buttons on an iPad? Right? If you tell them, okay, like pop the balloons in this game, like at what age can a child do that? Maybe 2, right? They see the balloon, they smack the balloon pops. Right, they're saying, the biggest challenge for the humans adopting this technique for a general reference resolution task in the context of popping balloons lies in resolving references to entities on screen, aka balloons, and using their properties, aka they can pop. In other words, getting the child to informally speaking see. Yeah, so again, I feel like this could be said easier without losing context. So why not do that? So I'm actually not going to be reading this stuff out loud because, man, do they make it complicated. I'm just going to try to kind of summarize it. They're saying that they're going to take the screen that you're looking at and they'll try to translate it into text, right? So you can think of it as that screen being sort of represented visually as text. And those things are going to be represented or tagged, right? So that the large language model has, or the language model, right? Because they're saying a smaller language model could perform very well at these tasks so that that language model has context. So for example, if you say call the business number, right, it understands where on the screen that is, what it should click on, just based on looking at the various things that are on the screen that are represented to it as text. They have some related work where they talk about like what has been done already and what some downsides are. They talk about using some synthetic screens rather than natural real-world images, which could be easier to parse. Obviously, kind of in the wild, the screens could be much different than when they're a synthetic collection of screens that they have, because they have, different distributions, meaning different people will choose to put certain buttons in wildly different places or put those annoying pop-ups asking for your email everywhere, which, by the way, is one of the big reasons I'm so excited about AI agents. I mean, it's not a big reason. It's just like the frosting on the cake is all those stupid pop-ups will be completely useless if you're interacting with the web through agents. And before, of course, how has this approach been done in terms of, computer vision? So they're using bounding box detection, right? So trying to kind of like put a box around certain things. So there's a button somewhere, right? If we kind of like outline that button, then the computer knows kind of the location of that button. Like this is probably a good example of it, right? So you have these bounding boxes over various cars as they're moving. So it's tracking them as they move. And OCR, optical character recognition. So basically being able to recognize characters on screen, letters and numbers. And of course, vision plus text models like GPT-4 Vision, they're substantially more expensive with respect to parameters and computational costs. So that's a good point. If you're trying to run something on device, like on an iPhone, and you needed to be doing like a million different things per day, using the biggest, most expensive model imaginable might obviously limit how much things you can do, right? This, to be super effective, needs to be very, very cheap. And the smaller, the better, obviously. If it can fit on device without needing an internet to run, that would be a big, big plus. And then they, of course, separate the task into on-screen entities, right? Obviously, so this is what you see on screen, buttons to click on, numbers to call. You also have background entities. The examples that they give is, like an alarm that starts ringing, right? Your phone might be making a noise, but may not be a visual representation of that on screen, or probably a better example of that is music that is playing in the background, right? So the vision model has to be like aware of that, even though there might be a visual representation of that on the screen, right? As well as they call it conversational entities, but it's just any other context related to the user. Like if you say call mom, whose mom is it going to call? I would do a yo mama joke here, but I'm not coming up with anything. And then data sets. So of course, to train these models, we need large amounts of data to train them on. And so here they're saying they're using either annotated human data created with the help of annotators or synthetically created. What's really interesting to me is that, years from now, 5-10 years from now, because you got to keep in mind, a lot of this technology is very new. The large language models, transformers, they haven't been around for decades. I mean, really, like 2022 is where a lot of this really starts scaling up. Like a lot of this obviously was around beforehand, but that's when it kind of hit that inflection point and just rapidly start increasing. As all of these things get better, our ability to produce high quality synthetic data to train these models on will get better and better. OpenAI's Feather, that thing that they haven't talked about yet, but I think that's their AI assistant annotators. Like you give it just a bunch of videos and the AI goes through and annotates everything. They're saying, if it's like a hospital footage of a patient in a hospital bed, right? It looks at each frame and goes, here the patient is getting a shot. Here the patient is getting food. The patient's wife is holding a pillow over his face, right? And, in the next frame, the patient appears to be lying still with the heartbeat machine flatlining, right? Imagine how useful that would be, right? If you can just annotate all of that video automatically, cheaply, at any scale with something like OpenAI, their model. Obviously could lead to some also pretty scary scenarios because, in terms of surveillance, boy, would surveilling every single person get really, really easy. Also, not to go on a tangent here, but pretty much everything you've said for the last 10 plus years, you've said in the presence of some sort of a device like a Google Assistant or a Siri or Amazon, Alexa, whatever. Actually, you know what? I'll just stop it right there. Point being, we'll be able to annotate massive quantities of data with AI tools, for better or for worse. And so a couple of models you got to be aware of. So of course, their proposed model is, I'm just going to say Realm, right? Because I guess you could say it as Realm, but I'm going to say Realm. The Realm was like one of the first MMO RPGs online. That has nothing to do with what we're talking about. Just thought you should know. Then there's Mars, which is a non-LLM based, and there's ChatGPT. So they're testing GPT 3.5 and GPT-4 as well. So Mars is a system that was proposed in another study. So I'm guessing it's the best available non-LLM system that we have. And here are the results. If you want to see all the details that went into doing all this stuff, I'll link the paper in the show notes, so take a look at that. But basically, they have multiple different data sets and different sort of testing data that they've used, and so they separate into 4 different ones. The first one, so this is the conversational data set. Synth is the synthetic one. Screen is the on-screen one, so kind of like picking the right number to call on screen. And unseen is a conversational data set pertaining to a held out domain. So I think what they're saying here is they're testing it, how well it can generalize, right? So if we train it on a bunch of stuff in one area, how well can it kind of generalize to another area? If we have a dog that we train to run 3 different obstacle courses, and we just keep training him on those 3 obstacle courses, and then we take him out into the wild and we give him some other obstacle course that it's never seen before in its life, how well is it going to be able to do on this obstacle course? In other words, does the dog being trained on these 3, does it generalize to every other one that it hasn't ever seen before in its life, right? So I think that's what that's saying here. And so Mars does, 92, 99, 83, 84. And you can say, GPT-3 does worse, GPT-4 does better, right? So for almost every single one of these, right, that holds consistently, except for the synthetic data set where both GPT-3 and GPT-4 completely drop off. So there's some weirdness there. But anyways, here's the realm at various different sizes, right? From 80 million, which is tiny, all the way up to 3 billion, which is still not big compared to some of the newer models. We believe GPT-4 is 1.7 trillion. Grok, I think 300 billion. Mixture of experts, I think there's 7 billion each. So combined, they're like 56 billion or something like that. I might be getting the number slightly wrong, but it's in that ballpark, right? So this is 3 billion. It's not big. And 80 million is just nano. It's tiny, which again, the point is, the smaller it is, the easier it would be to run on device without, needing an internet connection. If a phone can run these models, that's a big deal. Once this gets past a certain threshold, it won't be able to run on device, or at least not effectively, not cheaply. But as you can see right away, the tiny 80 million model, it's not even a large language model, right? It's just a language model. It beats out, or it's almost the same as GPT-4. It's in the same ballpark. Now, for some reason, GPT-4 like failed this synthetic test. But if we ignore that for a second and compare kind of like apples to apples, I think conversational data set. So, I mean, the tiny model comes close to being GPT-4. So GPT-4 is 97. The tiny model is 96.7, so very, very close. But the very next step, the 250 million parameter model, it's 97.8, so it beats GPT-4. The 250 million parameter model beats GPT-4 on the screen tasks, and the unseen, kind of how well it's able to generalize, the realm 3 billion comes close. So again, this feels kind of big in terms of finding kind of a new approach to building these models. Instead of using a massive model like GPT-4 with vision, we create a smaller language model that is able to do something like this. These tiny, small models can be very effective for this specific approach, for this specific set of tasks. All right, so Realm is better than GPT-4 for domain-specific queries. So for example, if you ask the model, can you make it brighter, right? Of course, GPT-4 might think, oh, you mean the screen brightness, right? Whereas a model that is specifically made for, let's say, the iOS devices might be like, oh, it probably means like the home brightness, right? So the home automation accessory that makes the room that you're in brighter because it knows which room you're in, etc. So in summary, TLDR, what does this thing mean? Some of you might have just skipped the video to get to this point. This kind of means that Apple might be trying to create a new approach to having these on-device autonomous AI agents, or maybe not autonomous fully, but basically a super smart Siri that is able to understand a lot of context, that is able to go online, do some research for you, interact with websites, but also change the brightness in your home, as well as play music on your various devices, just having a much greater understanding of what you want it to do. And because they're able to do it with tiny, tiny models, it can run on device, meaning that it doesn't have to be connected to the internet. It's going to be very, very inexpensive. And these tiny models are either similar to, or in some cases better than GPT-4 at understanding what needs to be done. And these models beat GPT-4 out of the box for domain-specific queries. And it's roughly similar to each other, Realm and GPT-4, right? So Mars, the other kind of state-of-the-art non-LLM approach to doing this, it kind of sucks, right? But for that, but GPT-4 and Realm, this Apple's approach, they're similar for new use cases, right? For doing tasks on an unseen domain. Whatever the case, I think it's exciting to see Apple publishing AI research papers because other people can use this approach. Maybe they can build a small model to help computer vision, right? Kind of incorporate it into their own devices. So everybody publishing these details and kind of talking about them is good for the field in general, for the field as a whole. In terms of how big this could be for Apple, it's too early to see. Certainly this is promising, and certainly they have a lot of things going for them. If they execute on this, if this works, if they can create on-device agents that run your life, that can act as sort of assistants for you, well, I feel like that would give Apple a big, big boost. Certainly they have enough cash to make a lot of this a reality. And the fact that they dropped the autonomous electric vehicles kind of shows that they're serious about AI, I think, probably. Similar to how Meta/Facebook and Zuckerberg, they dropped VR, right? As soon as people started realizing that AI is going to be a big deal, right? It's like, let's dump all these little projects we've been working on. Let's throw out the autonomous cars. Let's throw out the virtual reality devices, or not throw them out, but at least reshift our focus to AI. But this seems promising. This seems interesting. Let me know what you think in the comments. Are you guys excited about Apple potentially kind of moving in the direction of AI, trying to become a bigger player? Do you think it will succeed? Do you think this is a big nothing burger and it won't really help them? Or do you think this might be the new sort of approach to doing computer vision for AI agents? Certainly, I'm impressed with how tiny this is, the 80 million parameter model, how well it does at those specific tasks compared to, right, if I'm doing my math correctly, so this model is 0.004% the size of GPT-4. So it's measured in like the thousandth of a percent, the size of a GPT-4. I hope I'm doing that math right. I'm sure someone in the comments will correct me if I'm wrong, but that is impressive. The fact that it can reach for specific tasks similar results to a model that is like gargantuan in size is certainly impressive. I mean, and I think we're going to see this play out in the future too. Microsoft has been showing some of the similar things, that small models can be incredibly effective for if they're trained for specific tasks on, synthetic data even. So with that said, thank you for watching, and I'll see you in the next one.